All right, question 13 on the GRE practice test number 1. This is section 5. We're dealing with the quantitative problems. Kind of a fun problem after that disaster that was question 12. Question 13 deals with some geometry. First thing you needed to be able to do is read the question. So this little statement right here means that the lines M and K are parallel to each other. They appear to be parallel in the picture, but generally you can't assume that they're parallel just because they look like they're parallel. The other thing that we know are all of these are straight lines. If something looks like a straight line on this test, it is a straight line. You don't have to worry about anything being curved or whatever. With that information, we can solve the problem. The way I like to think about this problem is when you have parallel lines and a line that crosses both of them, a transversal I think that's called, that line intersects each of the two parallel lines in kind of the same way. What I'm saying is if you just focus on this little circle right here in red, and then you focus on this equally poorly drawn circle here in green, the two pictures are the exact same. This angle up here that's labeled S in this picture is identical, congruent is the fancy math word for it, to this angle down here. And this top right angle that has a measure of t degrees is congruent with this angle up here on the top right. Ends up not being relevant to the problem, but bottom left here is the same as bottom left here, and bottom right here is the same as bottom right here. So using the information that's given, I could label this angle right here as t degrees. Because again, top right is the same as top right. That comes from a thing called the parallel postulate, but I'm not sure that you need to know that. If you stare at this picture, you have an important piece of information. These two angles are what are called supplementary. What that means is they add up to 180 degrees. You can sort of see that from the picture, right? We do half of a circle going from here to here. We got 180 degrees in purple. So angle measures S and T must sum to 180 degrees. S plus T equals 180. I'm told that S equals T plus 30. So instead of writing an S right here, I could write T plus 30 plus T equals 180. And now all that I have to do is solve for T. If I subtract 30 from both sides of the equation, I'd have 150 over here. And then I got this T plus this T. So I have 2 of these T's. Divide both sides by 2. I get T is equal to 75 degrees. Looks like the correct answer is answer C. I know you're kind of pressed for time on these tests, but it's not a horrible idea to make sure that that makes sense. This is less than 90 degrees. Yeah, that looks right. This looks like it's a little bit less than 90 degrees. These aren't always drawn to scale, but generally angles that appear to be acute are going to be acute, and angles that appear to be obtuse are going to be obtuse. And let's see, if T were 75 degrees, it tells me that S is T plus 30, so S would be equal to 105 degrees. Yeah, that looks about right. It's more than 90 degrees, which I was hoping it would be. Seems like a reasonable solution. Then the last piece of information is S plus T should sum to 180 degrees, half of a circle. Sure enough, 105 plus 75 gives me that desired 180 degrees. Before ending this problem, there's a few more things that I should definitely point out here. I made the point that the red circle and the green circle are kind of the same as far as angle measures go. Top right has to be congruent to top right, top left has to be congruent to top left, bottom left congruent to bottom left, bottom right congruent to bottom right. But there's actually more. Using this line M right here, I knew that S plus T had to add to 180 degrees. But if I use this line, the transversal, I could see that this angle T plus this angle, whatever the hell I want to call it, also adds to 180 degrees. So you can kind of think about this S right here as whatever I need to add to T to get my 180 degrees that I see pictured right here. But wait a minute, this angle would also be whatever I have to add to T to get the 180 degrees that I see right here. The point that I'm trying to make is these alternate angles must also be congruent. And that's got nothing to do with parallel lines. Anytime you have two lines crossing, we don't need this second parallel line for this. This angle is always going to be congruent with this angle, and this angle is always going to be congruent with this angle. These two are always going to sum to 180 degrees. These two are always going to sum to 180 degrees, and that fact forces this to be the same measure as this. So if I really wanted to label my picture over here, I could label this one with an S and this one with a T. And then I could be like, wait a minute, the red circle is supposed to be the same as the green circle. So this one must also be T, and this one must also be S, and this one must also be S. I didn't end up needing any of that information to solve the problem, but I can imagine a different problem where you really have to take advantage of all the different congruencies in these pictures. So it's really useful to know. When you have intersecting lines, they always create two sets of congruent angles. These opposite angles must have the same measures. When you have parallel lines, you create 4 sets of congruent angles, right? Top left, same as top left, top right, same as top right, bottom left, bottom right, bottom right. And if you're really a stickler here, you might be like, well, yeah, it creates 4 sets of congruent angles, but really they're just 2 sets of congruent angles. These 2 are always the same as these 2, and these 2 are the same as these 2. That's true. That's entirely true. But if you had this fact over here, you wouldn't need to add that over here. So I think the easiest way to remember things is these opposite angles are congruent, and these parallel lines create, loosely speaking, these identical circles in red and green. The last general statement that you might need for geometry problems like this is that lines create supplemental pairs of angles. What I mean by that, maybe I circle it in purple, is that pick whichever of these lines you want. It doesn't matter which one. Maybe I pick this line right here. These 2 angles must sum to 180 degrees. Nothing special about that line. I could have done the same argument for this line. These 2 have to sum to 180 degrees and so on. And there's a bunch of geometry facts that will not just solve this problem, but hopefully solve other problems for you.